Okay, hello, this is Mr. Stewart with the 2.0 quiz on scientific notation. You're probably watching this if you didn't understand the quiz the first time you took it, or perhaps you don't feel ready so you want to review now. Either way, thank you for following along and listening. So this is going to be the second part of the extension quizzes that you'll only probably be seeing if you're in Math Honors. Alright, so we're looking at this. It says write the number in standard form. So you've got two forms. You got multiple ways to write numbers. This number right here is what we call scientific notation. Okay, so we will have talked about this in class, and there is a discussion board video tutorial that explains what scientific notation is and how to find it. But this is scientific notation. These are all examples of standard form, just your typical, this is what we understand. So, to address this, let's make up another question and just kind of show you how scientific notation works. So I'll do I'll do like this. I'll do 4.3 times 10 to the 4th power. So this is our example here. 10.3, so again, I don't solve these questions for you, but I give you something similar and let you sort of use the knowledge and the explanation to help you solve for this one right here. So, alright. So this is scientific notation. This is a big number that's been reduced down to something a little bit smaller. And I think the smaller the exponent is, I think you'll discover the less likely it is that you're going to be seeing scientific notation, just because it really doesn't turn out to be that big of a number in retrospect. But scientific notation is used for huge numbers and tiny numbers. So we're talking, especially if you're using something like distance in outer space. That's going to be referenced as huge numbers, or even speed, like the speed of light, for example, or how long it takes for the sun to get. So how far is our Earth from the sun? How far is our Earth from Pluto? How far is our Earth from the nearest, closest solar system? This distance, these numbers are going to be so big that it would take a long time to write them out. So we use scientific notation. We use scientific notation to denote large numbers so that they don't take up a ton of space. And that's the main reason we're using scientific notation. Another thing you might see this in is something small, like measuring very small things, like, I don't know, the diameter of atoms. Okay, so these are very small things, and they can be measured, they can be quantified, but the numbers are so small that it would take a long time to show, to actually write out the diameter of an atom. So we use scientific notation to denote that as well for small numbers, and that's when we start working with the negative exponents. But in this case, this is a positive exponent. So here's what it's telling us: 4.3. The decimal is very important here. This is telling us that if we were to take this number and multiply it by 10, take 10 and multiply it by itself 4 times. So 10 times 10 is 100. Times 10 is 1,000, times 10 is 10,000. If we were to take 10,000 and multiply it to 4.3, the result between these two numbers would be our standard form. Okay? And that's essentially what's happening. So we're using the power of 10 to be able to take huge numbers, and of course repeated multiplication can just be denoted with shorthand exponents. So that's what's happening here. Another way that people look at this is they think about this number up here, and I'll use a different color now. So the exponent sort of tells us how many places to move the decimal. So here's our decimal place, and this is telling us if from where it's at, let's move it to the right to make it a bigger number 4 times. So 1, 2, 3, 4. So that's where the new decimal goes. So if I erase this and then rewrite this number here with zeros after it, because those are the place values, then now what I'm looking at is 43,000. So 4.3 times 10 to the fourth power is another way of writing 43,000. Or if you think about it this, 4.3 times 10,000, that is 43,000 as well if you were to do the math. At least I'm pretty sure. We can double check with a calculator. So we do 4.3, I'm pretty sure it's right. 4.3 times 10,000, that's 43,000. Yep. So this is how it works. This is scientific notation. There are videos that explain it perhaps even better than me, but there you go. Alright, so write this number in standard form. Again, and maybe I don't need to go through an example again, but this one does have something different. So this one has 3 numbers. So you're always going to see the scientific notation is always going to be a number between 1 and 10, but it's never going to be something larger than 10 or equal to 10. It's always going to be 1.0 or to 9.99. It's never going to be anything larger than that. And they usually stop at the second place value. I don't think I've ever seen scientific notation with anything larger than that. So as we're looking at this, let's do one. I'll say 6.71 times 10 to the, let's do 7th power. Just making that up. Okay. So we can take this decimal and just think about, okay, 6.71. Then we need to move this 7 times, and it's going to be a larger number since it's a positive exponent. So 1, 2, 3, 4, 5, 6, 7. And then I'm going to put my zeros in there. So 0 here, 0 here, 0 here, 0 here, and 0 here. And that's going to be my new number where the decimal is taken away. And this is going to be 67,100,000. So you notice this is a big number. And writing it shorthand may seem like an easier path. If you get used to this idea, then these numbers are just as easy to work with as these numbers. If you get used to it, it does take a while to get used to. So you'll need to sort of create your own standard form. And I want you to notice these numbers right here are not changing, right? 6.71, 671, 601. So it's just the place of the decimal. Okay, so here we go in standard form, but this time, notice you've got yourself a negative exponent, and that's going to change some things. So this is actually looking at a very small number, and you look at all of these examples, all of your results have they are very small numbers. So scientific notation can denote small numbers too. So let's do that. Let's do 2.22, I'll just say that, times 10 to the negative third. No, do negative 4th power. Okay. So in this case, you need to remember one thing we learned about exponents. And 10 to the negative 4th power is like saying 1 over 10 to the 4th power. So, or in other words, 1 over, let's see, 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. It's 1 over 10,000. So this is a small number. 1/10,000th is a small number. So this is creating a small number where it's going to take this decimal that way and put a bunch of zeros up front and make this number small. I mean, it is already small, but it makes it appear to be small. So let's look at this. So it's a 10.22 times 10 to the negative 4th power. Well, this is just saying, all right, go in the negative direction 4 times. So 1, 2, 3, 4. Right out of room there. And then I just put the zeros in front. And don't forget, that's where your decimal goes. So I'm going to write this like this. 0.22 point 1, 0, 2, 0, 3, 0, 2, 2, 2. This is a small number. So the negative exponents that show up there make numbers small, or show or denote a small number. Okay. So you'll want to evaluate your own here. Okay, now it wants you to write this number in scientific notation. So this is now going backwards from what you're used to. So write the number now in scientific notation, which we can do. Let's make one up. I'll do 670,000. I'll do that. Okay. So you get to do your own here. But what you're looking at, you got to think about this number right here, and you got to think, okay, if I'm going to denote this using scientific notation, the first thing I need to know is that these two numbers are going to be the most important. They have to show up. And I can't just do 67 point something or 0.67 times 10 to the whatever power. That's not going to look good. Okay? The scientific notation always uses a number between 1 and 10, but that is not equal to 10. So I'm going to write this as 6.7 times 10 to the, and this is where we need to figure out, times 10 to the what power? Well, if I look at my decimal place, where's my decimal currently? Remember, the decimal always, every number can be written as a decimal. So this is, decimal 0, 0, 0, etc. But I need to move this guy over here. So this is 1, 2, 3, 4, 5 times to get to 6.7. So if I did 6.7 times 10 to the 5th power, that would effectively show this example here. Notice it's a big number, so it's going to be a positive exponent. It's a large number, larger than 0. I'm sorry, yeah, larger than 1. Okay, so any numbers larger than 1 are going to take you to positive exponents. Any numbers smaller than 1 are going to be a negative exponent. But and you can always test this if you want to. 6, 7, take the decimal 1, 2, 3, 4, 5 back. Is that the same result that I'm getting here? Is that the same number? Yes, it is, so you can always check that. Okay, so you'll want to evaluate your own and figure that out. Hopefully this is being helpful to you. Okay, last one, I believe. And so here's a small number. And so we'll do this. We'll do this one. Make one up. I'll just do 0.0. Sorry about the bell there. 0, 0, 0, 0,
Brinley Johnston,
8.
Office, Brinley Johnston.
Okay, so you're going to take this decimal, and we need to show a whole number between 1 and 10 times 10 to the something power. All right, that's kind of what we're looking at here. So we need to kind of get that decimal down there. So if you think about it, we can go 1, 2, 3, 4, 5, 6. It would take
Braxton Hayes, Cameron Lewis, Coden Mel.
Okay, so this is going to take you back, let's see, 1, 2, 3, 4, 5, 6 times. And so I'm going to write this as 8 times 10 to the, and remember, in this case, this is actually going to be a negative 6 power, times 10 to the negative 6 power. Because you need to remember, this is a small number. And 10 to the negative 6 power is going to be like 1 over, let's see, that's 10 times 10 times 10 times 10 times 10 times 10. So it's going to be 1 over 1 million. 1 millionth. Okay, so this is taking you out to the millionth decimal place. So times 10 to the negative 6 power takes you to the millionth decimal place. You want to do that and just double check. You count yours and do it that way. But yeah, hopefully this is helpful to you guys, and thanks for watching.